Welcome to a Saturday evening. It's time for some mail and some work I've been doing. So if you're not aware, KDE had a really big update this week. The home machine was fine, the VM was not, and the work machine blew up. Yes. So I don't know what happened on the work machine, but what the symptoms were is I lost the whole desktop. Everything was gone. Sidebars, bottom bar, everything. But I know enough about KDE I rebuilt the whole thing. The VM, on the other hand, OpenVM was misbehaving. I had to tweak the profile for it and stuff, and it took a bit of a while to get it straightened out. But this Linux box worked fine. Everything's peachy keen. Oh, I did get the capture working again from this guy right here. It works in OBS, but I cannot get it to work in the Video for Linux tester. So I'm not sure what's going on there. But let's begin with some stuff, because one of the projects I was working on was it was quite a long chain here. I had this, lots of these, remember, and I wanted to put them up on CircuitPython.org download. I want to learn how to build the UF2 file for this and how to go about it. But one of the things I needed to figure out was if I was to put the stock Python for RP24 on here, which I've done before, and it works, the pins don't match. So I'm not sure how that goes on when you determine the pin layout for this. So I needed to figure that out. So I wanted to use this or this, because these both have sets of LEDs built onto them. And what you can do with these two is you could then say, well, I want to blink the LED for pin 1, right? And then I could go back to this one and say blink the LED pin 1 again, see if I actually get an LED on it, right? Now this particular one, it looks like it's a straight through mapping to here to the LEDs, and down here's the power. In theory I should be able to put this onto here, but I need to figure some stuff out. So I wanted to hook up to the thing our friend, the signal acquisition gizmo, the Cyprus, and I end up rebuilding the SIGROC, both the one on here, the AMD 64 base, and I rebuilt the Python one. That took a little bit of effort because I had to relearn, because I've forgotten how to do it, how to set up a build environment for Python so that I can actually build it. No, build an environment for ARM so that I can rebuild SIGROC. Yeah, that's better. There's some Python involved, but yeah, it's annoying, because if you build it on the Raspberry Pi, last time I did it was real slow. This time when I worked on it, I couldn't build it in the virtual environment, but I could build it on the Pi, and it actually built fairly well. Now I understood one piece that didn't pass, which was the test harness at the end, but that's not really that important. Everything works properly, it shows up. Yep, okay. So first thing I'm going to do is just look at the mail. I need to find that second Cyprus thing, but that involves looking at mail, so let's all look at mail. And we need our knife, and these are cables of a particular type. I had that these things. This is I think is dead. I actually got a programmer for it, but I wanted a cable that plugged into here, and this is one of the batches of them. Okay. So let's find how to unwrap this. Here we go. Okay, so this is one without any ends on the end. So it should plug into this way or this way. This way. Yep, it does plug in. Like so. Now I have some others coming with other ends on the end. Like these are just bare wires. The thing is, I don't need this many of them, right? But that's the minimum batch. Okay. And they do come with a bunch of solder on ends, which is the exact same as this one. So push that over there. Now I had the other banana gizmos over here. I'm not sure what I did with them exactly, but these are Banana Pi Pico W's, I think is what they are. This is 2 processors on this. Yeah, Banana Pi Pico W. So effectively, it's kind of like the Pico W itself, but this is one uses an ESP to do the wireless component, not a proprietary thing. So no pins. I have to get some pins for this, but yeah. So we have an ESP on here. Wow. I can't even read that. Where is that tool? ESP32-S3. So it's quite powerful. I'll have to try this out. This is interesting alternate. But at the time I bought this, it wasn't out. Now that I got it, another component is out, which is Raspberry Pi released the new SDK for the Picos, and that included the new Bluetooth and stuff on it. So, although Adafruit hasn't got started on it yet because it's so bleeding new. I'll just put that over there. There we go. These are the camera modules. There's a camera, sorry. Don't want to damage that. These are built actually around a different ESP. I'm not 100% sure. Apparently I've got now 3 levels of this thing. So this thing goes into here like so. I think that's how it goes. I think you place it there. Wow, this is tricky. Nope, that didn't do it. Not even close. There we go. That's better. There we go. And then this just sticks to this thing. It's a little different than these ones. This is not the same, as you can see. This one, I believe, is an 8266, and this one is not. This is a Rover. And then I've got the couple. I think a couple of the really high-end ones. The new ones built around the ESP32-S3. So now, I thought all I had was this model, the Pro model, Lolin S3 Pro, and it turns out I actually have the regular Lolin S3s also. But that was, of course, I went and bought some regular S3s because I thought I didn't have them. Oh, I can save this bag and stuff. So, these are, I can take one out. It doesn't really matter. This is the regular S3. The CircuitPython image is on CircuitPython's download site. In theory, these guys are basically identical. You can see there's a slightly different way they built them, but it's the same chip, I believe. It's the ESP32-S3 Room 1, and even the same memory 16R8. But this one has a stem slot up here, has 2 ports, blah blah blah. This one has the battery on here, the stem on here, the SD card on here, and the video on here. Put those there. Okay, this. If I remember correctly, these guys here are, I think, on par or more powerful in speed than a Raspberry Pi Zero. They're effectively one of these. They are the Pine 64 OX64. So you can put an SD card in here, and you can actually load Linux on these things. It's got the space for it and everything. You can actually put a Linux on here, and then it runs pretty fast. I think these things are something like 500 megahertz or something like that. So they're about what? About $12. I think that's what these were. Now, this was cute. I really like this concept. So I have, these things, and I have various versions of these things, but I thought this one's cooler. So we have a little chip on the back to control the display. The Pico goes on here. The driver for this in CircuitPython is in CircuitPython. You can get the lib. It's straightforward. You got some buttons you can control here. You got some 5 volt, 3 volt ground here. You got some outputs, some lights, blah blah blah. Even a sound piece here, a speaker. And then it also came with a kind of well built little manual. Yeah, what they call the ILI 9341, which you can get from within CircuitPython. They give you a breadboard. They give you cables. The only trouble is this set of standoffs. The nuts don't match the threading. I think they inadvertently put metric nuts and or imperial standoffs, or vice versa. One of the two. And I didn't have that small of a nut floating around easily. But I thought this was cute. And here's the second one. just the same unit, another one. Yeah, so this is the Banana Pi, just the ESP version of it. It just has the S3 on it. I thought I kind of doubled up on getting these, so I didn't realize I had done that. And then this is exactly the same as that, except without the panel on it. This one, you just put the breadboard on here. So this is strictly a breadboard. Actually, I think I'll leave the little manuals out. Okay, what else we got here? They're all open because I have to tick them off and say I got them. So what was this? Oh yes, this is supposed to be an official ESP programmer. I think that's what this is. Yeah, this is the actual ESP3, programmer. I was going to use it on this to see if I can actually get this back. I'm wondering if just the base firmware is not hooked up correctly or something like that. I don't know. So I gather this one goes into here. Or is it this side goes into here? Ah, that one. And I suspect this one, the red, is the same thing here. Yeah. Boot, reset. So, ESP programmer from Expressive. So we'll have to try that out to see if we can fix this. I won't do it today, but I have to read up and learn how to do it. I'll just put that over there. Okay, what else we got in here? You've already seen the endoscope cameras. I just happened to throw them back in the bin there. Aha, last but least. And this was... Oh, right, this was for the printer stuff. This is the WaveShare board that's similar to the Pinaromi board screen. But this is what I was after. These things for building a logic analyzer. These little Cyprus boards. They're only about $6 or $7 on AliExpress. A couple of bucks shipping. Dime a dozen. Ooh, the pins stick out quite far. Reset button. See, basically the same boards. Buttons are a little different. Crystals are a little different. This one's definitely older. So now what I was going to do with this, This is kind of part 2. I accidentally stopped the video at this point. Let's move in a little bit here. Yes, I accidentally cut the video. So I left off in the last video was showing this, the logic analyzer. What we're going to add to it is this board. I had shown I was screwing in the screws in that, but anyway, this is the first 8 pins, and there's the second 8 pins on the board. So we're going to add them to this board. Now, this board has, sorry I have to go in glasses here, they have what they call PA, PB, and PD sets of 8 pins. Now, I know in the SIGROC Pulse View that PB is actually the first set of pins, PD is the second set of pins, and I think PA is like the third. It's kind of backward. It's a little weird. So we know we want this block here on the PBs. So I'm going to put them on. Just going to take the glasses off to do this. So I know that the brown wire is 0. So we just have to find PB0 on here. PB2, PB0 right there. And then the red wire was PB1. Orange wire being PB2. Yellow being PB3. And then we have to flip over to the other side, and PB4 being green. And PB5 being blue. Purple being 6. And white being 7. So that's the first block. Then we have to do the second block. And the second block, we'll start with the colored ones here. So we have green for 0. So PD0. Which is right there. Yellow being PD1, up and offset. Orange being 2, right beside green. And then we've got red and brown. So red goes here on PD3. And this should go here on this. And then the last 3 wires, we've got, I'll take the block of black and white. So white is the next one, which is 5. And then 6. And then the last white is 7. So here we go. We got our logic analyzer hooked up to our Pico breakout board. Now we need a cable or 2. So let's see. That's no good. I think this is what happened last time. I was pulling cables and I bumped the recording button. Okay, so this one we'll use on the Pico. And then we need a old school one for the logic analyzer. Okay. And we'll go to here. Don't need that. Don't need that. And we need, no, actually I do need this. We'll open the drive up. And we'll open the code up. Open workspace from file. CircuitPy. RP. Here we go. So effectively, I'm not blinking LED number 8 here, so keep that in mind. Okay, so now we need the SIGROC, the pulse view. I don't think I have a pulse view open. No, I don't. So we have to choose a device. It's going to be this one. Oops, got turned on. There it is. And let's do a run. There we go. And you can see I got the wiring right this time. Number 8, which I turned off. It's not showing any. Every time the thing rises, light goes on. Every time it falls, light goes off on the LEDs. So I can actually detect all the pin states through the logic analyzer. Now, for some reason, it only goes up to 16 channels in here, which is okay. Doesn't really matter. It would be nice if it could actually do all the ping. But after 16 anyway on this breakout board, it gets a little jumpy. Like, after 15, it goes 16, 17, 18, 19, 20, 21, 22, 26, 27, 28. So, I mean, in theory, if this thing recognized that I had all of them, but I think that would require a change in somewhere in here how many pins to use. But I'm not sure where that is. It only does so many samples and then it stops. So 1 million samples, 20 kilohertz. You have to change these numbers around if you want to. Configure channels. Yeah, so it only does 16 logic channels here. But you can actually change these all around, like the way it works. You can even assign channels for decoding, for example, I2C or SPI bus signals and stuff like this. So there's that too. I think that's in add a protocol decoder, for example. So, and if you think this is a fluke that 8 was doing that, we can go back here, for example, and Control S. And go back to our signal scanner again and start another run. And you can see that now 8 is blinking. Ta-da! So I rebuilt the SIGROC for both the ARM and the main PC, which is AMD 64 or X64 or whatever you wish platform, Intel basically. So I have it for both platforms. Let's see. We don't need it anymore. We can go stop. Yes. We're not saving any data. So I'll just turn off this thing, unplug that component, carefully move my cable over, don't knock anything. Now, I talked about fixing this guy. I actually did fix it, but oh, right. William's being bad. He needs to close this off properly. Close workspace. Safely dismount. So it turns out It wasn't dead. When at first I had done a flash erase before when I was testing this, and it wasn't erasing. It got stuck. I slowed it down, like the baud rate, and sure enough, I finally got it to flash yesterday. And then once I got it flashed, a couple of tries, I got it to flash the bootloader, and then put the CircuitPython on, and now it all works correctly. So I recovered one. Woo. So this is working again. I think this is the one I might have done. Yeah, there's a little black ink in there. Okay. You can't see it, but I can see it. So yeah, I haven't put an SD card on here yet, and I haven't put I've got the cables as I show for this part. I have more of those cables coming, ones with other ends on it and stuff like that. So we're gonna find out. I just wish I didn't need so many ends. Oh well. And there's the CircuitPython right there. We go like this. We click on that. So this hasn't, for example, this one hasn't even been loaded into Visual Studio Code yet. So open a folder, CircuitPython, open. Now, I explained yesterday on here, this file right here and this particular section right here seems to gets recreated. So if you add any parameters into Analyst Diagnostic Server Override, it gets wiped out. Now, apparently in the latest Visual Studio Code, code.py conflicts with code in Python. So I'm not sure what's going on there, but what you have to do is you have to actually put another one in here, like this report missing module source. You have to say report shadow imports none. But if you put that in here, it'll cure it for a moment, but then it'll get wiped the next time things get loaded or changed. So if this here, the 2019 2023-0219 module pack for CircuitPython gets updated, this will get rewritten. Now, I found that if you make a workspace file, this has a tendency not to get modified anymore. Sometimes. I'm still not 100% sure what Microsoft's philosophy on this is, but I can go File, and I can say, oops, get out of the JSONs file here. And we go File, and we say Save Workspace, and we go, let's say, Lolin ESP32-S3 Pro. And we say Save. So it'll build the stuff, it checks bundles again, and this time this file gets those lines and stuff. I've put it both in these files because this one seems to override the settings file, but it wasn't 100% sticky. So instead what you have to do is you have to go File, Preferences, Settings, like so. And you go Diag, and you go to Pylance, and you say Edit the Settings JSON here. And I won't save this file, but you add this line in it, which I already have done. The only reason there's a space is because it thinks I was adding another entry to it. In reality, this file looks like this. So this doesn't get overwritten because the extension doesn't touch this file. But this settings JSON file overrides this settings JSON file, which is sometimes overridden by this workspace file that overwrites this JSON file, but doesn't overwrite this JSON settings JSON file. Blah, 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 blah. So now you don't get any error about code overwriting code. Another trick you can do, apparently, if you don't want to do any of that, change code.py to main.py. The extension will recognize that, and it's perfectly happy with it. So does CircuitPython. It doesn't have to be code.py. It could be main.py. You should go in here, and it's like Lolin. It's this guy here, basically. So now the workspace pile gets this into it. Gets an extra line in here. The settings gets nothing. Nothing changes for it. So that fixes that quirk in the thing. So I got that part fixed. Yeah, I'll have to join these two sections of video together. I hate video editing. I don't need that. Close. Let's close this off. So now, what else did I miss when I was recording? Yeah, I went through all this. To write that firmware, you have to do this. In fact, I'm going to save this particular line because I want to keep a copy of that. And then, yeah, see, I wrote it at 115 baud here. You can see that down there. Nor you write it at 480, I think. Before that, yeah, I did this. This is the one that didn't work the first time, the flashing. But once I slowed it down, it seemed to work this time. It was a bit tricky getting it going, but doing any of the ESPs with their stupid way they do the buttons and stuff. Yeah. Now I think with the correct boot and everything this time, I think if you go 2 quick resets, same thing I had yesterday. Could not get this thing into yeah. It's so freaking hard to get this thing into the Lolin boot mode so you can put new UF2s on. Nope. Same thing I had yesterday. No matter what the spacing of the reset buttons, I could not get into this. Okay, we'll keep going to the CircuitPy drive. come on. This is like stupid. So I think I put it in programming mode. Yeah, so yeah, I give up. It's like, is the hardest thing to get into. Yeah. I wonder if I was just holding the button in and plugging in, we'll get it that way. Nope. How about the other button? Oops, my finger slipped off the button. Got it. Oh, I think I discovered a way why it's not doing it. Okay, let's do this from scratch again. Their instructions are wrong. If you double click the reset button, so let's say here we're on Circuit Pi, like that. So what you want to do is reset, 0, Lolin boot. That's how you get to the bootloader. So their instructions are incorrect. Because if we go to the web page here and you scroll down to here, this section right here, right? That's incorrect. To get it into the bootloader, it's click, click, click. And the LED will go red and it'll go into Lolin. I have to make a note of that. It's reset, 0, not that. So where's my notepad? To get to boot loader mode. Reset. Then I think it's called 0. Then boot 0 button. There we go. Save these notes. now we know. I'll have to remember that now for these guys. This probably applies to other these boards too. I have another one here, for example, this one. Let's put this one into that mode. So yep, same thing on this one. So unplug it, plug it in. Normally they come up with CircuitPy, so we go, there we go. Okay, at least this works on the Lolin boards. I have a feeling it works on the other S3 boards that I was having also trouble getting to. This is the non-pro, by the way. It has two of these and just a stemma port. Range is slightly different, but same stuff on top, same size, same everything else. Whew. And I think it's time for me to get some tea. So I'm going to pause for a sec here. Pause. Okay, so we have tea. And I showed this earlier. I want to see if I can get the display going. So we have a Pico on here. So I think our first thing to do is on our Pico is to make sure it's up to date. So I know we light the screen up and stuff. I've seen that already before. Oh, we are in RPI mode. Okay, so we don't have anything on here, or it's not working right. So okay, so we need a firmware file for this, and I'm going to go over to this site. And I'm going to have to out zoom it again, reset. So we go like that, and there's our Pico. And we download the UF2 file. You're not seeing the download screen, but I'm just going into controllers, Pico, RPI Pico, CircuitPython, and saving this file there. So we need RPI Pico. Yeah, organization is best. So we need this file here, copy, and we need to paste it into here. It should reboot and give us the CircuitPy drive in a moment. There it is. This is new. The settings Tomo. That's for wireless, if I'm not mistaken. So now that we have the thing set up, we go back to CircuitPython. Sorry, I mean Visual Studio Code. I mean, William, click on the right thing. Where are you? There you are. Okay. So we open folder, and we open the CircuitPy drive, and we create everything. Okay. Choose a board. Pico. There it is. Save out a workspace. Now, I was reading up on how to do workspaces with multiple projects. What I'm kind of curious about is how do you handle multiple CircuitPy drives? Let's say you have 3 Picos and you have 3 CircuitPy drives and you all have the same project, basically. I don't know. I was looking into that to see what I could do. This is RPI Pico. The little blinky, 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 blinky. updates this. So here's our hello world. Let's check our VS Code settings thing. There it is. Dunk. Okay, so I think the first thing we need to do is test if well, there is a blink on the thing for, well, for activity, but we need to, let's say, put a blink program on here. Now, since we don't have a NeoPixel on here, we just have a regular LED, so we need just the regular LED blink program. So I happen to have that. That's that one. And oh, frick, off. I thought he turned that off on that thing. Oh, the editor keeps whining about tabs, and I'm going spaces. I'm going ignore code. Nope, not that one. That's the Blink INO. Platform IO ESP2 sample new 3. Ignore pins. Programming new 4. Platform IO. Come on, William. Where did you put the Blink program? Well, you lost track of another Blink program. Okay. That's okay. So, go here. And we go here, and it's simply a matter of looking it up. I could almost write one in my sleep, but I don't remember quite the right coding. So, we need this. And I swear I had this before. So I'm going to go and open a new one here and Control V into my notepad and save it. So we've got our Blink. Nope, wrong one. Go here, here. Well, it's on, but it's not blinking. Let's see. LED is GP25. Let's connect to the REPL and see if there's an error. So the LED is on, but it's not blinking, so import board dir board. There's the LED, but there's also GP25. So let's change this to GP25. And we'll run again. We're not blinking the damn LED. That's not a blink. Let's change this code up here for this code. There we go. Now we're blinking. We didn't even have a blink section. We turned the LED on and that was it. Now, according to this uses the ILI something. So we're using which one? ILI 9341. So we're going to need that library. Now, I can do it with CircUp, but believe it or not, the extensions thing has it too. So if you hit F1 and you say show available libraries, and we go ILI, there it is. Library is now installed. You don't actually have to go to CircUp at the command line to add a library or manually copy it over. If we now check our lib directory, there it is. Right there. So we need an example to turn this screen around. Let's go check out on Mr. here. ILI. So this exists here. This is like with a feather wing, but it will work for our purposes. So we've got everything installed. Oh, we need a couple of more things in here. Let us install. And we'll do RGB. So RGB display, install version. And we will do bus. And we will do register. Okay, all those are in. Okay, so what else do we want to do? Uses SPI initialization, display initialization, drawing. It's going to be a complete one here. This is using the display I/O. I think this would work. Let's try it. Copy. And we'll go over here to our blink. Control V. Now we need to get the pins right. So, right here. And let me switch back to that. So I put all the code in from that sample. We need to get the pins straightened out here. Here we are, touchscreen, LCD display. We have TFT-CS. It's GPIO 13. Oops. Then it's GP. For the DC, it is... what is DC? I don't know. I have more pins than I'm using. TFT, DC, LCS, RS, write, SDI, reset. I don't know. Let's try WR. It sounds like right. So that was 15. We have an error still. 14. Oh, out of display text. Oh, okay. we're missing a library. Okay. Okay. Control C, Control D. Line 20. SPI. It doesn't like that. I don't think we have a directly like that. Import board dir board. Yeah, according to our pin outs, we don't have an SPI pin per se. So on the Pico, we need to specifically define SPI. So we need a SPI line for this. Okay. Let's just duplicate this. Whoops. The frick. Duplicate. Thank you. Pico SPI. Let's see. Blinky traffic light reaction gain, potential PWM LED temperature gauge. Is it temperature gauge? I got SPI. Data logger. No, not finding it. I need an example of CircuitPython and SPI. Unlike the feather boards, it doesn't have a specific SPI pin, so CircuitPython Pico SPI. Yeah, here we go. So we need bus I/O in here also. And then we need, this is how we have to do it here. This becomes bus I/O dot SPI board dot now the only thing I don't know here is which SPI we're on. Okay, I could probably determine this by the pins 14, 13, 15, and 17. So what do we got here? 14. Okay, there's SCK, SDA1. And we have 12 and 13. We have 13. SCL0. SDI 7. SCL1. So we need the SCK. Well, let's go for SCK1, Mosey 1, blah blah blah. Let's see if we can get that. Board. And then board. Then board. Okay, let's see what we break now. No SCK1. No, of course not. Oops, where's my card for Pico again? SCL, SCSDA. So it's clock 1, SCL1. I don't think it's SCK1, I think it's SCL1. But I don't think we have that pin. No, we don't even have any of those pins. I don't see Mosey pins, or I see... so if it's all 1, and we're using 1, then SCL1 is GP3. And Mosey 1 is Mosey in. Would that be GP8? Eight and 7. GP8 and GP7. So let's see what happens there. And invalid pins. Still line 21 invalid pins. Bus SPI. So their code on their page is wrong, and this is not right. GP13 is the CS pin. Yeah, so I am in this block right here. SCK would be 14. Sorry, not 14. 10. GP10. Okay, and in is 12, out is 11. So in is 12, out is 11. Still invalid pins. There's 10, there's 11, there's 12, there's 13, there's 14. Okay, so clock pin, Mosey pin, and I'm using GP10, which is a clock pin. Okay. You wouldn't want it this way, would you? Hmm. I mean, they are saying SCK1 in here, but it doesn't make sense. Board.SCK1. Yeah, but there's no SCK1. Okay, let's do this slightly differently. SCK1 equals board dot GP10. MOZ1 equals board dot GP12. Mozo1 equals board dot GP11, I think it is. Yep, GP11. And then down here we go line 25. Well, I might have keywords in here, so let's go A underscore A underscore. That'll get us out of the keyword area. A underscore Taurus. Still invalid pins. Okay, that didn't work. I should be able to do this, but why have I not been able to do that? The pin used for the clock, the pin used for the main out, main in. So, what the heck is going on here? This doesn't make sense. CircuitPython board, yeah, okay. GP10 is a pin. Line 25. Invalid pins. It doesn't like them. And this guy has them as Well, I'm kind of stumped. I have to go fix things out. Why is that not working? Let's find a different sample code maybe. So pins are swapped around? Okay. Blue column, SCK is 14. GP10. Output is 11. Input is 12. And CS is 13. Okay. I should be able to put this in there. No, I don't understand why that doesn't work. I'll try another SPI bus. Well, the other one is like 26 and stuff, so 26. Ugh. And I'm gonna just change this around. So out is 27. Oops, 27. And in is 28. Still fucking invalid pins. Oh, CS over here is 21. $17. SPI 21. Still doesn't like this. Doesn't like it. Wonder why. I mean, in theory, this should be 10. The wiring diagram says it's 10. In D01, which is output, is 11. And this should be 12. And this should be 13. But it doesn't like it. I can put board.GPO in there, GP10, but it doesn't like it either. I wonder it's because of this, because I'm doing bus I/O. I mean, I'm pretty sure it just doesn't like raw pins like this GP10. Not defined, of course. GP12, GP11. No, it doesn't like it. Right? It's expected to have it defined. So board dot right board dot board dot and then we're back to invalid pins again. Okay, SPI. Oh, I wonder. Board.SCK, but GP10. This one here. MISO equals. No, MISI. So we did I before. Yeah, so this is I. And MISO equals. Extra arguments given. Clock. Oh, clock, is that a capital clock or is it a lowercase clock? If you're wondering, I'm using Control Spacebar to bring down the pick list. Still wrong. This does not make sense. Well, there's another sample code here. Let me just grab this code. Control C, Control A, Control V. Yeah, I mean, this is what I was doing. Okay. Line 19. Well, this turned out not as easy as I thought. But I got past the SPI. GP2 in use. Okay. Clock is 10. Mosey is 12. And that's 11. And according to the little booklet, CS is 13. Now it's invalid pins again. Reset is 14. DC is, we don't know what it is. And we're back to invalid pins again on 13. Well, I'm going to call this video now because I got to do a bit of reading and find out what's going on here. It doesn't make sense why I'm getting this. Because I know that that's a valid range for an SPI port. In fact, that's SPI 1. But they also have SCK1 on 14 too. So they're doing 14 on reset, 13 on CS, 6 and 7. 7 being SDI. I don't know. I have to go do some reading on this. This does not make sense. You know, when you want to demonstrate something, Murphy's Law steps in and says you can't do it. Control S. Yes. So, this is a kind of a weird two-part video. Now I have to get stitch videos together. So, I'll see you later. Bye.